Good morning, everyone. Welcome. Today, we're going to dive into a topic that, honestly, is at the very heart of smart business strategy. We're going to be building a bridge between the math theory you've been learning and how it's actually applied in the real world. Our goal is to use a really powerful tool to answer one of the biggest questions a company faces. How do you find that perfect sweet spot? That point where you're making the absolute maximum revenue. And trust me, this isn't just an academic exercise. This is a skill that will set you apart. So, here's our game plan for today. First, we'll start by talking about something I call the revenue paradox, which might flip some of your basic assumptions about business on their head. Then, we'll get into the math that actually models this paradox, the quadratic function. After that, we'll roll up our sleeves and work through a real case study. Applying this model to a revenue function, we'll find a solution and then, and this is the most important part, we'll talk about how to translate that number into a smart, actionable business strategy. That's where the real magic happens. Okay, let's jump right into our first section. I want you to pay close attention here because this concept challenges a very common and frankly, very wrong assumption that a lot of people make when they first start thinking about business. Getting this paradox is really the first big step toward a much smarter way of managing revenue. Now, at first glance, this seems like a no-brainer, right? Of course, if you sell more stuff, you make more money. It feels intuitive. But in the real world, in any competitive market, that's a huge oversimplification. The truth is much more interesting. Pushing for more and more sales can actually, believe it or not, cause your total revenue to go down. Why? Well, think about it. To sell more, you might have to start offering discounts. You might have to spend more on marketing. Eventually, you might just run out of people who want to buy your product at the original price. Understanding this complex relationship is what separates a decent manager from a great one. So if we agree that a simple, straight-line model where selling more always equals more money is just not realistic, then what's the alternative? What does the shape of revenue actually look like? Well, this question brings us right to the core mathematical concept for today's lecture. It's a tool that gives us a much more accurate picture of how revenue really works. Okay, so let's talk about the quadratic function. In math terms, it's just a function where the highest power is 2. Something is squared. When you graph it, you get this beautiful curve called a parabola. Now, that parabola can look like a U or, and this is the important one for us, an upside-down U. It's that inverted U shape that perfectly models our revenue problem. Think about it. The curve goes up, which is your revenue growing as you sell more units. Then it hits a peak. That's your maximum revenue point. And then it starts to go back down. That's your revenue decreasing as you have to cut prices or the market just gets saturated. This model perfectly captures that point of diminishing returns we see in the real world. This slide really puts it all into perspective. On the left, you've got the linear model. It's a nice, simple, straight line going up forever. You could call this the wishful thinking model. It assumes there's no competition and you can sell an infinite number of products without ever lowering your price. But then you look to the right. That's business reality. The quadratic model shows that beautiful, realistic curve. It acknowledges that to sell that next unit, you might have to lower your price. And that price drop doesn't just apply to the new sale, it applies to all the units you're selling. That's the complex world you all will be navigating, and this is the model that helps you make sense of it. All right, enough of the theory. Let's make this concrete. We're going to move into a real-world example from our source material and build a function that we can actually work with and solve. So here it is, our revenue function for this case study. R of x equals 900x minus 0.1x squared. Now in this equation, R of x is our total revenue, and x is simply the number of units we sell. But before we just start plugging in numbers and solving for things, it is absolutely critical that we understand what each piece of this function is telling us from a business perspective. So let's take a moment to really dissect this equation. This table does a fantastic job of showing the two opposing forces at play here. Think of it like a tug-of-war. On one side, you have the plus 900x. That's your engine. It's the positive force driving your revenue up. You can think of that 900 as your base price. For every unit you sell, you get $900. But pulling in the opposite direction is the second term, negative 0.1x squared. This is what I call the market resistance factor. It represents all those things that push your revenue down as you sell more. Price cuts, market saturation, you name it. And look closely. That negative sign is everything. It's what makes this a downward force. And the x squared part tells us that this force doesn't just stay constant. It gets stronger and stronger at an accelerating rate the more units you try to sell. Okay, so here's the million-dollar question. How do we find the absolute peak of that curve? We need to find the precise point where revenue is at its highest right before it starts to tip over and decline.
In the world of mathematics, that peak point of an upside-down parabola has a special name. We call it the vertex.
Luckily for us, there's a straightforward formula to find the x-coordinate of the vertex. It's x equals negative b divided by 2a. So let's walk through this. In the standard form of a quadratic, ax squared plus bx, our a is the number next to the x squared, and b is the number next to the x. So for our function, a is negative 0.1, and b is 900. Now we just plug those into the formula. X equals negative 900 divided by 2 times negative 0.1. Now, a very important point here and a common place for students to trip up. The answer we get for X is not the maximum revenue in dollars. It is the number of units we need to sell to get to that maximum revenue. That's a critical distinction.
And when you do the math, you get one clear answer: 4,500. And there it is. That's our magic number. That is our strategic target. According to our model, the absolute peak of our revenue happens when we sell exactly 4,500 units, not one less, and, this is the key, not one more. Selling 4,499 units would mean less revenue, and selling 4,501 units would also mean less revenue. This is the top of the mountain. Now, as I've been saying, for all of you future business leaders in this room, getting this number isn't the finish line. Not even close. In fact, it's the starting pistol for the strategic conversation. Our job now is to translate this mathematical solution into a clear, confident, and actionable business decision. I want you to really picture this scene, because you will find yourself in meetings just like this one day. Imagine you're the product manager. Your VP of sales, a great, ambitious leader, comes into the meeting and says, "Let's push for a target of 6,000 units this quarter." Now, the old way of thinking would be to just say yes, more is better. But you, armed with this analysis, can step in confidently and provide real value. You can say, "I love the ambition, but I've run the numbers. Our revenue model shows that to hit 6,000 units, we'd have to discount so heavily that our total revenue would actually be lower than if we aimed for 4,500 units. I have the data right here to walk you through it." You see the difference? You're no longer just sharing an opinion. You are guiding strategy with data. You are preventing a costly mistake. That is invaluable. Okay, before we wrap up, we absolutely have to talk about some common traps, things that trip up students and even experienced professionals when they use these models. First, and this is the big one, revenue is not profit. We found the point of maximum revenue, but we haven't said a single word about costs. The ultimate goal is always to maximize profit, so this is just step one. Second, remember that any model is a simplification. Our model assumes the market isn't changing. But what if a new competitor enters? What if consumer tastes change? You always have to consider those external factors. Third, and please write this one down as it's a classic exam mistake, don't confuse your X and your Y. We solved for X, which is the number of units. If you're asked for the maximum revenue itself, you have to take that X value and plug it back into the original function. And finally, never, ever blindly trust a model. It's a guide, an incredibly powerful one, but it's not a crystal ball. Use it alongside your business judgment. And that really leaves us with the final critical thought for today. We've figured out how to maximize our company's top-line number, our revenue. But as we just said, the real price, the ultimate goal of any business, is the bottom line, profit. So what's the next logical step? What's the next critical question we have to ask? It's all about costs. How do we figure out our costs, model them, and then combine that with our revenue model to find the point of maximum profit? Well, that's exactly what we'll be tackling in our next lecture.